Welcome students. Today this is a very important class for the 5th semester B Pharm students, pharmacognosy and phytochemistry 2. This is the unit, the last unit actually. I have taken in one lecture, it's wider, which already you have come across all these drugs, specifically like Digoxin, Dioscorides, tea. Most of them you have studied in detail. This is a very important topic. Why I am telling is, I have seen that within this 4-year question papers, lots of questions have been asked from this chapter relating to the other chapters also. So this is about the industrial production, estimation and utilization. How you will produce the particular phytoconstituents from that particular medicinal plant or the crude drug, and its estimation, qualitative, quantitative estimations, and its utilization, therapeutic applications. They have given all the constituents like Forskolin, Sennosides, Artemisinin, Diosgenin, Digoxin, Atropine, Podophyllotoxin, Caffeine, Taxol, Vincristine, Vinblastine. We have studied most of this from the plants like vinca, tea, Podophylline, Datura stromanium, belladonna, digitalis, Dioscorea, Artemisinin, Senna. These all drugs you have studied their details. This is about an revision, as well as they are asked many questions connected with this chapter, which is a summary from the previous chapters actually what you studied. So it is necessary for the students to write a clear cut assignment by listening to my lecture, complete and write yourself, prepare the notes, and it should be submitted to my office without fail. That includes your, I can say very clearly, it is then one of the important work for the sessional marks, including that how and continuous assessment. In that, it is needed for you to submit this assignment by listening. I am not giving any without material. I have not told this is the material. You can listen and you can understand, and then you write your assignment and your own notes and submit. And some of the questions you just see, I have taken only for 5 or 6 question papers. I have seen more than 37, 38 questions, including 10-mark questions 2-3 times. It was surprising me. So I want to share with you. You see, industrial production of pharmaceutical application of Podophyllotoxin, 5-mark question they have asked in January 2020, in the corona period, the first exam for the 5th semester in cohorts. Source and family constituents and uses of taxes, 2-mark question they have asked in same question paper January 2020. And in next question paper, he explained the industrial production method and pharmaceutical application of vinca alkaloids, 10-mark question. So the student should know all the details about the vinca, whatever you studied, including all its microscopical analysis also it's needed, and industrial production and its utilization. You should write very clearly 10-mark question 2021 they have asked, and explain the biological source and uses of Dioscorea, 2-mark question in the same question paper, January 2021. List out the 2 uses of Forskolin, 2-mark question, January 2021. You see the same question paper. Again they have recalled the drug used for cerebral malaria and its sources. Artemisinin. Artemisia is the cerebral malaria treatment. We are using artemisinin. Actually that is one of the drug which is choice for the cerebral malaria. So 2-mark question, January 2021. You see that question, how many questions they are asking in one question paper. And explain the industrial production and utilization of Taxol, 5-mark question in November 2021. And in same November 2021, they was explained the industrial production of pharmaceutical application of Vinblastine, 5-mark question, you see. And explained the biological source and chemical constituent uses of Dioscorea, 5-mark question. 3 5-mark question in the same question paper, November 2021. Just imagine how much this chapter is important. And in the same question paper, 2-mark question, again they have asked biological source of family of tea, 2-mark question in November 2021. Discuss the industrial production of utilization of Vincristine, again 5-mark question in July 2022. Mention the constituents of tea leaves, 2-mark question in July 2022. Explain Artemisinin, 2-mark question in July 2022. Explain the industrial production, estimation and utilization of Digoxin. See, digitalis is a complete detail you have studied. Industrial production, estimation, utilization. They have asked 10-mark question, January 2023. Discuss the industrial production method and application of Senna-glycoside. Senna, you have studied. Senna-glycosides. How you can industrial production, because you are studying extraction sources, extraction, isolation, instrumental analysis. That is what we have studied in the chapter. Previous chapter I taught you that about the extraction, isolation, characterization of the compound. So these all should be applied. Your basic knowledge what you have occurred in this semester. Discuss the industrial production method application of Senno-glycoside, 5-mark question in January 2023. Explain Dioscorea rhizome, 5-mark question in January 2023. Taxus, 5-mark question in January 2023. Explain the production and estimation of Podophyllotoxin from its source, 5-mark question in January 2023. Give the structure of Sennosides, 2-mark question in January 2023. Explain industrial production and estimation of Artemisinin, 5-mark question in September 2023. You say, again, September 23, again 5-mark question. Give the source and method isolation of caffeine, 5-mark question in September 2023. In again September 2023, write the chemical constituents uses in Podophyllotoxin or Podophyllum, 2-mark question. And write the biological source, chemical constituents and uses of Dioscorea, 2-mark question in September 2023. You just see that. Again the September 2023, chemical constituents of Vinca and its uses, 2-mark question in September 2023. Explain in May 2023, before, explain the industrial production of utilization of Atropine, 5-mark question in May 2023. Explain the source and family uses of Artemisia, 2-mark question in May 2023. Therapeutic uses of Vincristine, 2-mark question in May 2023. Chemical constituents and uses of tea, 2-mark question in May 2023. How many questions they are asking in one question paper? Imagine, in May 2023, 4 questions. In September 2023, 4 questions. In before that, 5 questions, like that. You can see, in December 2023, describe the method of production of estimation of Taxol, 5-mark question, December 2023. Describe the method, isolation, analysis of Podophyllotoxin, 5-mark question in December 2023. In December 2023, again explain the industrial production estimation of Vincristine, Vinblastine, 5 mark question. December 2023. So it is very, very interesting chapter. You again 2 mark question, describe the method of estimation of Forskolin. 2 mark question in December 2023. Explain the industrial production and estimation of Podophyllotoxin, 5 mark question in July 2024 recently. And chemical constituents of Taxol, 2 mark question in July 2024. And discuss the industrial production of Digoxin, 5 mark question in November 2024 they have asked. Taxol, 2 mark question in November 2024 they have asked. And even chemical constituents uses of Vinca in 2 mark question in November 2024. So you just see that how much the importance of this chapter. So I am insisting the student, you have to write an assignment as an instruction, not only instruction which I am giving. Kindly write your own notes, make yourself elaborate it by means of the previous chapter which you know, which you studied detail about the particular compound, and I am giving some information, some of the important information. Collectively write an assignment and it should be submitted as a continuous assessment mark. This is an important parameter. So this is the chapter industrial production, estimation and utilization. So they have given a category: production, estimation, analysis, determination of quality, quantitative analysis, and then utility, utilization. What is its application? What is its category towards the human being? Towards the application. What is the use therapeutic application? These 3 categories of constituents like Forskolin, Sennosides, Artemisinin, Diosgenin, Digoxin, Atropine, Podophyllotoxin, Caffeine, Taxol, Vincristine, Vinblastine. So first we will see that Forskolin. This is the structure. It is an iridoid structure. It is an, you can see that quinone derivative with a lactone ring. Forskolin is also comes under the iridoids, phenone derivatives. Forskolin is called coleonol. It can be sourced as coleonol. Sorry, not coleonol, coleonol or coleonol. In a labdane, diterpene, it is a terpene derivative, diterpene, that is produced by the Indian Coleus plant, which is called Plectranthus, or you can say Plectranthus, barbatus, Plectranthus or Plectranthus barbatus, very violet color flower. Leaves are soft, like you can see it will be spongy leaf, and roots is a very important part where we are interestingly isolating the Forskolin. Family is Lamiaceae. Forskolin is a chemical compound in the root of the plant Plectranthus. You should write Plectranthus barbatus. Otherwise it can be called as Coleus, forskohlii. Forskolin, you have to write Forskolin, a diterpenoid, an industrial produced through extraction from the roots of Coleus, forskohlii, followed by purification and refinement. So industrial production, what all the things you have to mention? First, the plant material, Coleus forskohlii or Coleus forskohlii is a sole, it is the only known source for Forskolin. So that's why you have to collect these roots, and its roots are the primary source for the extraction. So harvesting the roots and the preparation, the roots are harvested, washed, dried and then pulverized into a coarse powder. Extraction, the dried powder which you prepared, pulverized material, is extracted using solvents like methanol or ethanol, and the extraction process is involved technique like Soxlet extraction, which uses a continuous hot percolation method. You know very well this. You can explain, if it is 10 mark question, you can explain how the material is fed and how it extraction details you can write very clearly. Purification, the crude drug is purified using a technique column chromatography. This also you have studied about this column chromatography. You can explain if it is a 10 mark question to isolate Forskolin from their plant constituents using column chromatography. Estimation, qualitative quantitative analysis for Forskolin. The pharmacognosy, in pharmacognosy, Forskolin is a diterpenoid compound, is typically estimated using high performance liquid chromatography. HPLC also for precise quantification of Forskolin in extract. So HPLC can be used, and other techniques like mass spectrometry, UV visible spectrophotometry, and nuclear magnetic resonance can also be used for identification, quantification and purity assessment. So we have studied all this instrument. I have personally taught you. So you can just go for the detail about what is the necessary, what is the use of mass spectrometry, how can it can give the molecular weight, and how an UV visible spectrometry can give the absorption of the light by conjugated double bond system, characterization of the structure of Forskolin. And also you can see that NMR is an instrument which can give the details about the number of carbon atom, number of nitrogen, number of oxygen. All these things can be easily identified. Nitrogen, hydrogen, carbon, not oxygen. So this can be identified. I have explained about the instrument, how they are utilized for the characterization of the phytochemical like Forskolin. So it can be easily explained. Pharmacognostic application of Forskolin, utilization. It is used in cardiovascular health. Forskolin ability to rise the cyclic adenosine monophosphate, which is highly responsible. The level leads to vasodilation and decreased blood pressure, making it useful for the treatment of hypertension and related conditions. So it has relation with the cardiac health. Asthma and respiratory issues can also be treated with Forskolin by relaxing bronchial smooth muscles. Forskolin acts as a bronchodilator, aiding in the treatment of asthma and other respiratory problems. Glaucoma. Forskolin is employed to lower intraocular pressure, helping manage glaucoma. So now Sennosides, the second phytochemical we came. Sennosides, already you have studied Senna, you have studied the source, family, all the details, even in the practical also. So all this can be incorporated if they ask 10 mark question. They have asked. So you should know that. So this is a Sennoside structure. Sennoside A, Sennoside B, Sennoside C, Sennoside D. All this you have studied. How many? What is the linkage? What is its category in glycoside? Anthracene glycoside. What is its chemical test for? What is bone tracker test? What is the modified bone tracker test? All these things should be specified if it is a 10 mark question, which you have practical, can be applied in the theory. So Sennosides are obtained from the dried leaves of Cassia senna, Cassia angustifolia family, Leguminosae. You know there is senna, there is different varieties. In India we have Tirunelveli senna. Africa you can say Alexandrian senna, Cassia senna commonly you can say. There are many other different varieties are there. It has to be identified by means of its morphology and microscopy and chemical constituents, and identity can be found out with adulteration. Sennosides are dimeric. You see they are dimeric. Two dimeric anthraquinone glycoside, meaning they have divided anthraquinone with two sugar molecules. This is what the round which I want to show you. Two sugar molecules. They have two sugar molecules in both the side, dimeric compound with a glycoside linkage, anthraquinone glycosides. They are primarily found in the leaves and the pods of Cassia angustifolia and Cassia acutifolia plants. Senosides, especially Sennoside A and B, are used as a stimulant laxative. So they work by irritating the colon, large intestine, increasing peristaltic movement and reducing water absorption. Industrial production of senosides, preparation and initial extraction. Senoside leaves are dried and ground or reduced in the size or pulverized into powder. The powder is extracted using solvents like benzene, methanol, or a mixture of methanol and toluene. You have to remember this solvent system. The extract is filtered and residue, that is the mark, is separated. Further extraction and the concentration, the mark is further extracted with 70% methanol or other suitable solvents. The extracts are combined and concentrated, often under vacuum reduced temperature, to remove the solvent. Purification and isolation, next step, precipitation with calcium chloride. The solution calcium chloride in methanol is used to precipitate senosides, creating calcium senoside complexes. Then pH adjustment and separation. pH, this extract is adjusted with ammonia and it precipitates senosides are filtered and washed with methanol. Recrystallization. Senoside A and Senoside B are further purified through recrystallization with different solvents, you have to remember, like glycol monoethyl ether. Glycol monoethyl ether is a solvent which is used for recrystallization of senosides to enhance the purity. Isolation of Senoside A and B. The Senoside A is obtained by treating with calcium senoside precipitate using with an acidic gluconic acid. You have to remember, for Senoside A, acidic gluconic acid. While for Senoside B, isolated by using methanolic hydrobromic acid. So acidic gluconic acid for Senoside A and methanolic hydrobromic acid for Senoside B for isolation can be remembered. Drying and storage. The isolated senosides are dried and stored in desiccator because the atmospheric moisture should not disturb. It will be very hygroscopic after drying and after preparing. The long-term preservation you have to use usually desiccator as shown. Estimation of senosides. Senosides, the active ingredients in Senna, are typically estimated using analytical techniques like high performance liquid chromatography and thin layer chromatography after extraction from Senna leaves or pods. High performance liquid chromatography is favored for its precision and ability to separate and identify individual senosides like A and B. TLC can be precised than HPLC, can be used for qualitative analysis and as a preliminary step for more detailed quantification. Pharmacognostic application of senosides, already you might have studied, you can apply. This is a small information I am giving according to this chapter. You have studied and you have lectures according Senna. Senosides primarily found in Senna plant and utilized in pharmacognosy as a potent stimulant laxative for treating constipation and preparing the bowel before surgery or medical procedures. Laxative, I just shown a picture to show you the evacuating the bowel, and you can see the feces, how it comes out for a laxative and a cathartic. Cathartic with magnesium sulfate, like a liquid it will come for evacuating the bowel or enema. But laxatives are, you can see the stool can be softened due to the stopping the reabsorption of the water, and it can be, and increasing the peristaltic movement slightly, it can come to the laxity effect of Sennoside. They work by irritating the colon, increasing the peristaltic movement and reducing the water absorption, so that utility leading to the bowel movement. Artemisinin, next drug, we are coming to the next phytochemistry. Very interestingly, they have asked repeatedly, even Artemisinin, they have asked for what is the drug which is used for cerebral malaria. You have to write this Artemisinin. Artemisinin, the plant, small plant, you write, already you studied and malarial drug, cinchona bark. But this is only very interesting, more than cinchona, this is more applicable nowadays. It is a plant, ornamental plant also, most of them they are having in the house. And the flower without opening, it has more constituents, Artemisinin. Artemisinin synonym, the plant synonym is sweet wormwood, sweet anise, biological source or botanical source leaves, and the closed unexpanded flowers heads will have more constituents of Artemisinin, and actually the plant botanical name is Artemisia annua. Family Artemisaceae or Arteaceae, not Artemisiaceae, Arteaceae or Arteaceae or Compositae, usually they comes in the family. Artemisinin is a sesquiterpene, lactone with a unique 1,3,4 trioxane structure. You see, it has 1,3,4 trioxane structure characterized with a peroxide. Trioxane, you can see this is the trioxane structure and a peroxide bridge. So this is very important, which is having that activity for anti-malarial activity is due to this structural. The peroxide bridge is a crucial for its anti-malarial activity, systemic anti-malarial activity, which is why it is effective against multi-drug resistant strains of Plasmodium falciparum. Artemisinin is a molecular formula C15H22O5. You should know the chemistry of the phytochemistry, how it is having the therapeutic activity and the pharmacological activity, how it can be act as an anti-malarial. So you know the importance of knowing the pharmaceutical chemistry, background of the nature. Industrial production, the plant material preparation, fresh Artemisia annua leaves are collected and dried at a temperature at below 60 degrees centigrade. The dried leaves then powdered to increase the surface area for efficient extraction. Extraction is done by solvent selection. Solvent like ethanol, methanol or even ethyl ether, lower polar, and petroleum ether can be used for extraction. Maceration, the powdered drug material is soaked in a chosen solvent above and mentioned a period of 2 to 3 hours for benzene extraction. Solvent extractions, a continuous extraction method also can be followed where the solvent is heated, vaporized and condensed back into this solvent as we did in Soxhlet apparatus, resulting efficient solvent extraction process. Supercritical liquid extraction can also be followed. The method used carbon dioxide, liquid carbon dioxide under high pressure temperature as a solvent, leading to faster and more effective extraction can be done. Microwave assisted extraction can also be done in Artemisinin. Artemisinin can be extracted by microwave assisted extraction, which we have seen in volatile oil extraction methods. You can refer that. They are asking even 2-mark question, what is the use of microwave assisted extraction? So this technique use microwave energy to accelerate the extraction process. resulting in higher yield of artemisinin. Purification, liquid extraction. The extract is partitioned to immiscible liquids. Between two immiscible liquid solvents like partitioning, chromatography, ethyl acetate and water to separate the artemisinin based on solubility differences with water can be removed. So chromatography, column chromatography can be used. A solid stationary phase like silica gel is used to separate artemisinin from other component based on their affinity for the mobile phase. High performance liquid chromatography can be used, a more refined chromatographic technique for achieving high pure level of artemisinin. Recrystallization can be done as shown in the picture, cooling down, decreasing the temperature in a conical flask or the beaker, you will get the crystals of artemisinin. The purified extract is crystallized by slowly cooling a concentration solution resulting in a formation of pure artemisinin crystals. Estimation of artemisinin estimation in pharmacognosy typically involves extracting the compound from plants, often Artemisia annua, and then quantifying it using various analytical methods. These methods include thin layer chromatography, high performance liquid chromatography, and gas chromatography with mass spectrometry, that is hyphenated technique, combining the instrumental technique, hyphenated techniques. That chapter I have explained you. They will ask, what do you mean by hyphenated techniques? Combining, you see, this is a combined form of gas chromatography with mass spectrometry. The goal to determine the precise amount of artemisinin present in the sample, which is crucial for quality control and the drug development, which was more insisted by the international community and as well as the European Union and WHO. Analysis and characterization can be done by thin layer chromatography, a simple method to identify and quantify artemisinin using mobile solvent and visualizing technique. UV spectroscopy. UV spectroscopy is used to detect the quantify artemisinin in a solution based on the absorption of the UV light. You can find out the concentration. HPLC is used for both qualitative identification and quantitative estimation analysis of artemisinin. Pharmacognostic application of artemisinin, very interesting. Antimalarial activity, artemisinin and its derivatives are highly effective against all forms of human malaria, especially falciparum and vivax malaria. It is considered as a first-line treatment for malaria, particularly for the case of drug-resistant strains. Artemisinin combination therapy, ACTs, are referred to the treatment for malaria. Other therapeutic applications are there, like anti-cancer effect of artemisinin is a derivative, shows cytotoxic activity against various cancer cell lines, potentially through mechanism like DNA damage, apoptosis and inhibition of angiogenesis, blood vessel stopping development, unwanted vessel stopping the development, angiogenesis can be stopped as an anti-cancer effect. Antiviral effect, artemisinin has shown inhibitory effect against viruses including human cytomegalovirus. Antiparasitic, besides malaria, artemisinin has an effective against parasitic infections like schistosomiasis. You may be having this abdominal pain due to schistosomiasis. So this has an anti-parasitic protozoal action, anti-parasitic action also. Anti-inflammatory action is also there. Artemisinin inhibits anti-inflammatory property by inhibiting various signal pathways. That means you can say by inhibiting the prostaglandin synthesis, it can act as an anti-inflammatory also. Antibacterial effect is there. Cardioprotective effect is there. Apart from that, question they have asked many times, artemisinin derivatives like artemether and artesunate derivatives, artemether and artesunate, are highly effective for the treatment of cerebral malaria. That's why the question is asked from Kuhas. State a drug which is used for cerebral malaria and its industrial production. So you say, so the student should be ready for the answering. Now we are coming to the podophyllotoxin. Podophylline you have studied detailed in your drugs. This is about the industrial production, estimation and utilization in this chapter. So if you had asked 10 mark question, you have to write what you studied before also in the chapters. Podophyllotoxin is also an irinoids, lactone rings with double bond O. You can see the oxymethyl groups. Podophyllum hexandrum royle of the family Barbaridaceae is an endangered means declining, more utilized by the human being. So there is need of demand in the cultivation, need of demand of the plant. That is, it is endangered medicinal plant also known as Indian May apple. This is the flower, beautiful flower, but we are using its rhizome. The rhizome of Podophyllum hexandrum consists of several ligands and iridoids and polyphenols, or you can say quinones, which we have studied. Ligands which possess anti-tumor activity. Podophyllotoxin is a most active cytotoxic natural potent product from the rhizome. Podophyllotoxin is a natural occurring aryl tetraline ligand as shown in the picture structure. It is an heterocyclic or heterotetracyclic compound. You can see heterotetracyclic compounds. It has 4 O groups, 3 inside the ring and 1 is double bond O. You can see that. Naphthodioxole skeleton features 3, 4, 5 trimethyl phenyl substituent as shown in the picture. Industrial production of podophyllotoxin, extraction and isolation. Podophyllotoxin is typically extracted from the podophyllum species such as Podophyllum pentatum, male apple, May apple, and the Synopodophyllum hexandrum, barberry family or Barbaridaceae, which you have shown. Extraction involves using alcohol-based solvents to obtain podophyllin resin or podophyllotoxin in the resin, which contain podophyllotoxin. The extract is then purified and concentrated. Estimation of podophyllotoxin, identification and quantification method, thin layer chromatography. This method can be used for identifying podophyllotoxin based on the RF value and the color. HPTLC, high performance thin layer chromatography, which we have studied, the operation video I have explained. You just watch that very clearly. It's a very important technique. HPTLC is a more sensitive and rapid method compared to thin layer chromatography, allowing a better quantification. High performance liquid chromatography, HPLC is widely used method for quantitative analysis of podophyllotoxin. Other methods like spectrophotometric, gas chromatography with mass spectroscopy, mass spectrometry, the hyphenated combined techniques can also be used for podophyllotoxin estimation. Pharmacognostic application of podophyllotoxin, antiviral and anti-cancer activity. Podophyllotoxin is known for its ability to inhibit cell division, making it effective against various infections and cancers. Topical treatment for genital warts. Genital warts, you may be knowing about genital warts seen in most of the back of the person and even in the body. It's a key ingredient. Tropically, creams are available like Podophyllotoxin used treat genital warts caused by the human papilloma virus, HPV. Anti-tumor agents, derivatives of podophyllotoxin such as etoposide and teniposide are used in chemotherapy for treating various cancer including lung cancer, lymphomas and ovarian cancers. Other pharmacological properties besides its antiviral and anti-cancer effects, podophyllotoxin has been shown to have other medicinal properties like anti-inflammatory, immunosuppressive and antispasmodic effects also. Now we are coming to Digoxin, that is Diosgenin. Dioscorea is a plant which you studied in detail in your chapter. Suppose if they ask in higher version of 10 mark question, you should write all the details what you studied also. Diosgenin is a steroid ring. Phenanthrene with a 5-membered ring structure will be there like cholesterol. So steroidal sapogenin. Is it a glycoside? Sapogenin. Genin. Primarily involves harvesting plants from Dioscorea gingibernicis and Trigonola phonium graecum. Trigonolia phonium graecum means you should know fenugreek, and you should know that is very commonly used in our food. Uliva, which is used very commonly, we are using that in the food material. Dioscorea gingiberensis, the rhizome is used for Diosgenin constituents, is a saponin glycoside. Fenugreek, Trigonella phonium graecum, you see the picture, very common in our home. And very interesting nutraceuticals, very interesting medicinal property. Daily consuming is very interesting by soaking in the water in the night and morning if you take. Interesting, it will relieve even your chronic pains in our joints. It stimulates various physiological functions. It has lots of nutraceutical activity. That is fenugreek. You can see the structure of Diosgenin, a steroidal ring structure A, B, C, D, like phenanthrene A, B, C and the D 5-membered ring structure with the side chain. Diosgenin is a plant steroid with a chemical formula of C27H42O3. It is a spiroscan, a hetero or hexa ring cyclic or hexacyclic diterpenoid and a 3-beta sterol. Industrial production of Diosgenin, a steroid sapogenin, it is primarily involved in harvesting plant like Dioscorea gingibernicis and Trigonella phonium graecum, that is fenugreek, followed by extraction and isolation using techniques like acid hydrolysis. The raw material, often tubers of Dioscorea species, is dried and subjected to acid hydrolysis with sulfuric acid and hydrochloric acid at elevated temperature, resulting in isolation of Diosgenin. Estimation: in pharmacognosy, Diosgenin, a steroidal sapogenin, can be estimated using various techniques including thin layer chromatography, high performance liquid chromatography, and densitometry. These methods help quantify the amount of Diosgenin present in the plant sample or extracts. Pharmacognostical application of Diosgenin. Diosgenin, a steroidal sapogenin, is primarily utilized in pharmaceutical industry as a precursor for the synthesis of various steroidal drugs, including oral contraceptives, sex hormones, and glucocorticoids. It is also being explored for the potential in the treatment of various conditions like cancer, hypercholesterolemia, and inflammation, or hypercholesterolemia and inflammation. Digoxin, this also you studied very detailed, plant detail about Digitalis purpurea. If they ask an essay question, you have to write the industrial production, application, detailedly you should write the structure, all these things. Digitalis purpurea, foxglove, Digitalis lanata is also foxglove. Industrial production, we are using Digitalis lanata. Purpurea means purple color. Lanata is slightly yellowish, purplish color flower. This is the Digitalis leaf. This is the flower of purple Digitalis purpura flower. Belongs to Plantagenaceae family. Previously it was called as Scrophularaceae family. And industrial production, digoxin, a cardiac glycoside, is industrially produced from Digitalis lanata, foxglove, through a multiple step extraction and purification process. The process typically involves initial extraction of the powdered plant material with ethanol, followed by defatting, preparation of phenolic, and separation of cardiac glycosides, including lanatoside C. Because once the lanatoside C is there, you can hydrolyze. Through chromatography also you can separate. Lanatoside C is then hydrolyzed to yield digoxin. That is the step which you should remember. After extraction, isolating the lanatoside C, and then lanatoside C is hydrolyzed. This is the lanatoside structure. You can see a steroidal ring structure with a lactone ring with a quinolone, a double bond O, not quinolone, double bond O in a 5-membered ring structure. And it is connected with a glycon of glucose molecule with an acetyl group also. That is lanatoside C structure. When it undergoes hydrolysis, you see the structure very clearly, how it is breaking down. Hydrolysis means just breaking down of the glycoside linkage with the glucose molecule in the top. The structure which is showing 4 OH group, you can see there of it has been cut down and it becomes OH group and digoxin. The same structure, only the glucose molecule and acetyl molecule, the area which I rounded with the pink color, is removed. This is the acetate and the glucose molecule which is removed. That is the acetyl and the glucose moiety have been removed by hydrolysis. And you will acquire this OH, the joint, and OH hydrogen is attached, and so that you will get the digoxin. So digoxin, lanoxin C, is a cardiac glycoside that is structurally related to digoxin, and hydrolysis process removes the acetyl as shown in the structure and the glucose moiety from the lanatoside C, yield digoxin. This should be written. Very important reaction and very important structure the student should know in phytochemistry. Estimation In pharmacognosy, digoxin estimation often involves colorimetric analysis, paper chromatography and thin layer chromatography. Colorimetric analysis uses a reaction with xanthylrol or alkaline picric acid to measure the absorbance. Xanthylrol or alkaline picric acid, when you add, you are getting a color which can be easily absorbed by the lambda max of the color, and concentration can be identified. While chromatography separates digoxin for subsequent detection and quantification. Pharmacognostic application of digoxin. There are many applications you might have studied in the plant. And digoxin is cardiac glycoside utilized in the pharmacognosy for the treatment of heart failure and atrial fibrillation. It enhances myocardial contraction by inhibiting the sodium-potassium pump, increasing intracellular calcium and strengthening heart muscle contraction. Digoxin is also used to control atrial fibrillation. Now comes to atropine. You are studying even datura, stramonium, belladonna, propane alkaloids, all these things in alkaloid you have studied. So this is one additional topic which you are giving about the industrial production of atropine. Atropine exists in the natural in hyoscyamin. It's a racemic formulation. You should know that they are propane alkaloids in racemic form of hyoscyamin and atropine. They are present in the form of esters of tropic acid and propane. You should know that very clearly, the structural relationship of the propane alkaloids. Atropa belladonna, it otherwise called as deadly nightshade, belladonna, datura stramonium, Jensen weed. This is datura stramonium, white flower which we have seen in our normal places. This is belladonna, beautiful fruit, and the flower will be lightly pinkish with white color, slight white pinkish. Family Solanaceae. Atropine is a naturally occurring tropane alkaloid, a racemic mixture of D and L hyoscyamin formula C17H23NO3. Industrial production of atropine is industrially produced through the extraction and purification from plants like Atropa belladonna and Datura stramonium. The process involves extraction alkaloids from plants material using like 95% alcohol, followed by a series of extraction, filtration and precipitation to isolate and purify atropine. Estimation, atropine, a tropane alkaloid can be estimated in pharmacognosy using various analytical techniques like HPLC, high performance liquid chromatography, gas chromatography with mass spectrometry, hyphenated technique, combined technique, ultraviolet UV visible spectroscopy and NMR spectroscopy can also be used. Pharmacognostic application of atropine, we know that it is an anticholinergic agent. Atropine, an anticholinergic agent, is utilized in pharmacognosy for various purposes, including antidote for poisoning of organophosphorus insecticides and nerve agents. It is also used in the treatment of bradycardia, slow heart rates can be treated, reduce salivation before surgery, and in ophthalmology for the pupil dilation it is also used. Atropine can also manage diarrhea and gastrointestinal disorder, even sometimes for spasm also. Additionally, it is used in case of treatment of poisoning caused. Certain types of mushrooms poisoning can also be treated with atropine. Caffeine, you have studied tea, green tea, normal tea, production, all these things you have studied. This is caffeine. And you have done in the lab also extraction. You can write that also. This is simply an idea I have given. Industrial production, utilization, analysis. They are asking the question. So caffeine is an xanthine derivative, which will not accept all the chemical test for normal alkaloids. So pseudo-alkaloids, 3 CH3 group in 3 nitrogens. It's a purine derivatives and it is a xanthine basic structure. The botanical gene of the species can be Arabica coffee, otherwise written as Coffea arabica, family Rubiaceae. The tea plants are Camellia sinensis in a green evergreen shrub from the family Theaceae. Caffeine chemically is 137 trimethyl xanthine. A methyl xanthine alkaloids with a molecular formula of C8H10N4O2. Industrial production of caffeine. I am giving just an industrial production. There are many other productions, many other things which you did in the lab also can be done. Using water extract and using separating funnel, using chloroform, non-aqueous solvent, separating the caffeine, crystallization can be easily written according to the procedure what you did in the lab. Here I am giving a small procedure. Caffeine production of plants like coffee and tea involves extraction, isolation and purification. What should be done? You can write exaggerate. The process like harvesting, processing and isolating caffeine using solvents like water or supercritical carbon dioxide extraction can also be followed. Further steps of liquid-liquid extraction, as I told, liquid-liquid extraction means immiscible liquid extraction. Non-aqueous solubility of caffeine in chloroform can be utilized for liquid-liquid extraction, crystallization and column chromatography followed by purification to ensure high purity caffeine for pharmaceutical and also for the food purpose. Estimation caffeine TLC is also available. You have to write, and caffeine estimation, even chemical test by Mirexide test can also be implemented here. In pharmacognosy, caffeine estimation typically involves extraction from the plant source coffee or tea, followed by quantitative analysis using techniques like high performance liquid chromatography, UV visible spectroscopy and thin layer chromatography is also used for caffeine determination. Pharmacognostic application of caffeine is known as its stimulant. Caffeine is a plant alkaloid. Find various utilization in pharmacognosy due to its stimulant property and their pharmacological effect. In essence, caffeine is used as a central nervous system stimulant, bronchodilator and migraine treatments also can be used. Taxol, very important, repeatedly they have asked. And even I have taught some details even about Taxol, plant and the bark containing Taxol, anti-cancer action, structure have been given in iridoids. But it is very important, detailedly they are asking, because it's not a simple extraction. It is dealing with your 4th semester, what you studied in biotechnology, what you studied in and that is tissue culture is applied for the production of Taxol. It is also a plant which is having very less constituent but more medicinal activity. Utility is more, but the demand is more. There is no constituent present in the natural source. So they found fermentation process to produce this Taxol. That's interesting. This is a structure. You should know that it is an iridoid structure, double bond O, and you can see it is an very clear how many methyl group is present, complicated structure of a terpene. It is also called as Taxol, can be called as paclitaxel. Pacli. You can say paclitaxel. Paclitaxel or Taxol? They can ask the question. So you should know Taxol is an anti-cancer drug, anti-neoplastic or cytotoxic chemotherapy drug, very, very important and more useful. Taxol is classified as a plant alkaloid, a taxane, and an anti-microtubule agent. It stops the tubule formation in the cancer. Unwanted development of new formation of the tubule can be inhibited by means of Taxol. Taxol, also known as paclitaxel. Paclitaxel is a complex tetracyclic diterpenoid. Tetracyclic diterpenoid with a formula of C47 H51 NO14. Taxol is primarily extracted from the bark of Taxus brevifolia Pacific yew tree. Japanese, more it is present, while the needles and the branches also contain Taxol. The bark is main source. The amount of Taxol in the tree's bark is very, very low. Typically, it is around 0.01 to 0.05%. Very low in the bark. This is the picture of the bark, how is the reddish. Flower is also reddish. This is the bark that is about peeled off, and this is the bark which is ready for peeling. This is the flower of the plant. Taxol or Taxel you can say. Not Taxol, Taxel. Taxel or Taxol. A diterpenoid natural product has emerged a widely used anti-cancer drug with its unique mode of action and efficient against multiple forms of cancer. The vast growing demand in basic research and clinical chemotherapy requires to increase the global supply. As I told, the global supply is needed, but the demand is more, the quantity available in the plant is very less. Currently, industrial production of the drug with semi-synthesis with the extraction of Taxol, precursor from the yew trees, cannot meet the market requirement. Thus, alternative techniques have been intensively explored. One of the promising strategies is the use of fungal fermentation for Taxol production. Fungal fermentation Taxol production is an important procedure which you should study, listen to this class, listen to my lecture and write it clearly and please submit the whole assignment. Industrial production by fungal fermentation of Taxol production. This is why they are asking repeated question for 10 mark and 5 mark question. The student should write this production. How fungal fermentation of Taxol production. A fungal strain, Aspergillus niger, subspecies Taxi, it is named or it is coded as HD869, a Taxol producing endophytic fungus with a Taxol output of, it is giving an output of 273.46 microgram per liter. Good production with what was isolated from Taxus capidata side. Preparation and isolation of fermentation broth from strain HD869. We have taken the strain HD869. The first step, activation. How you can do? The strain of HD869 on potato dextrose agar medium composed of peeled potato, sliced potato of 200 grams per liter, glucose 10 grams per liter and agar 15 grams per liter at 28 degrees centigrade for 3 days you have to keep. The fermentation process will take 15 days actually. First 3 days it is kept for activation. Second step, Then after 3 days it is transferred to S7 fermentation medium. What is this S7 fermentation medium? It composed of sodium acetate 1 milligram per liter, zinc sulfate 2.5 milligram per liter, cupric nitrate 1 milligram per liter, magnesium sulfate 3.6 milligram per liter, ferric chloride 2 milligram per liter, manganese chloride 5 milligram per liter, lime nitrate 6.5 milligram per liter, sodium benzoate 10 milligram per liter, glucose 1 gram per liter, sucrose 6 gram per liter, fructose 1 gram per liter, and pectone 1 gram per liter. This is cultured, this is incubated at 28 degrees centigrade and with centrifugation, slightly agitation, slightly centrifugation at 338 into G means that is the specific uniform slight centrifugation for 12 days. Centrifugation at 38 in G means relative centrifugation force. In a small force is a relatively slow speed centrifugation. 12 days should be made. So 3 days and 12 days, 15 days you have kept. Third step, fermentation broth was extracted with an equal volume. Now the extraction step, the third step. Equal volume mixture of ethyl acetate and methanol. Volume is to volume, 1:1 for 3 hours. After extraction, fourth step, organic phase were extracted and collected by separating funnel now. And fifth step, organic solvent was evaporated under reduced pressure using rotary evaporator at 45 degrees centigrade to give 1.45 grams of dry sample. So 5 steps, isolate and purify this Taxol and then done by chromatographic techniques. You see this procedure, I made it one slide to make the student to repeat again a summary. First step, you're activating the strain HD869 in potato dextrose agar, that is activating. The species is Aspergillus niger species Taxi. HD869 on potato agar medium composed of peeled and sliced potato 200 grams per liter, glucose 10 grams per liter and agar 15 grams per liter at 28 degrees centigrade for 3 days, and then transfer this to a medium S7 fermentation medium cultured at 28 degrees centigrade with centrifuging at 38 xg for 12 days, slow centrifuging speed. What all present in this fermentation medium? It composed of sodium acetate 1 milligram per liter, zinc sulfate 2.5 milligram per liter, cupric nitrate 1 milligram per liter, manganese sulfate 3.6 milligram per liter, ferric chloride 2 milligram per liter, that is magnesium sulfate 3.6 milligram. Sorry, this is manganese chloride 5 milligram per liter, lime nitrate 6.5 milligram per liter, sodium benzoate 10 milligram per liter, glucose 1 milligram per liter, sucrose 6 grams per liter, glucose 1 gram per liter, sucrose 6 grams per liter, and fructose 1 gram per liter, and peptone 1 gram per liter. So these are the constituents, these are all the present in the fructose fermentation medium S7. After 12 days, extraction with an equal volume of mixture ethyl acetate and methanol, volume by volume 1:1 for 3 hours. And you know that non-aqueous organic solvent ethyl acetate and the extract are collected in a separating funnel Using a separating funnel, it can be collected. And then the fifth step, evaporate the organic solvent ethyl acetate using a rotary evaporator at 40 degrees centigrade, giving 1.45 grams of dried sample. So this is the 5 steps which the student should remember. Extraction from yew tree also it is done, but very low yield. Taxol can be extracted directly from the bark of the Pacific yew tree, Taxus brevifolia, while initially rely on harvesting yew trees. Suitable methods like culturing using byproducts by tree harvesting had been developed, as we have seen just now. Estimation is that the amount of Taxol is calculated by comparing the peak area of the Taxol sample to the peak area of the standard solution, with a standard and a sample solution in an HPLC, HPTLC of known concentration can be done. Example, HPLC method, chromatographic system of HPLC system with column C18 column, specific mode phase of example water and acetonitrile solvent. The detection of wavelength of absorption of the Taxol is 227 nanometer in UV absorption is used. Lambda max. Sample preparation, the sample is dissolved in appropriate solvent like methanol. Injection to the HPLC, a known volume of the sample is injected in the HPLC system. Analysis, the separation of the compound is detected by the peak area of Taxol compared with the standard solution. Pharmacognostic application of Taxol. Taxol works in stabilizing the microtubule, which is essential component for the cell division or cell's cytoskeleton. By inhibiting the breakdown of microtubule, anti-cancer effect, microtubule, Taxol prevents the cell division growth, unwanted cell division growth, effectively stopping the spread of the cancer cell. Therapeutic application, Taxol is vital chemotherapy agent like treatment various cancers including ovarian cancer, breast cancer, non-small cell lung cancer, Kaposi's carcinoma related to AIDS cancer, pancreatic cancer. These all can be treated, they are depending. Vincristine, Vinblastine, repeatedly they are asking this question. You have studied Vincar Ocaceae. Complete details about the Vincar Ocaceae is needed, about the microscopy, macroscopy. Vincristine, Vinblastine, their structure are similar, only a difference in their functional group. Vincristine is an aldehyde, Vinblastine is an methyl group. CHO group will be there in the indole substituted. There are 2 indoles are there, and in that indole substitution you can see that N is substituted with aldehyde in Vincristine and methyl group in Vinblastine. Catranthus roseus plant, prickle. We know that Apocynaceae family. Commonly it is called bright eyes, Cape periwinkle, graveyard plant. They can classify as an alkaloid, indole alkaloid, a large group of natural products consisting of several ring structures as shown in the picture, giving one or more nitrogen atoms. This is the thing. Vinblastine you have CH3 and Vincristine you have aldehyde, CHO, the round which I shown just now. You can see this is the indole structure present in the both of them. If you study in the detail about Vinca plant, there the teacher might have taught you about the different structures coming from the Vendolin, how the Vincristine and Vinblastine comes from Vendolin alkaloids, and it is an indole alkaloid. So this structure is very important. Industrial production of Vincristine, Vinblastine involves cultivation of Catranthus roseus plant, extracting the alkaloids through solvent extraction and purifying them through techniques like chromatography and crystallization. Plant tissue culture and tissue culture techniques are employed now to enhance the production, because Vincristine, Vinblastine also very low content in the plant, and these are valuable compound. Estimation: the pharmacognosy Vincristine and Vinblastine are typically estimated by using analytical technique HPLC. LCMS means liquid chromatography combined with mass spectroscopy, spectrometry, as I told, with an hyphenated techniques, combined techniques, or mass spectroscopy separate with HPLC. We can identify the drug quantitatively. UV visible spectroscopy is also used, and nuclear magnetic resonance spectroscopy is also used. HPLC is the most common method for quantifying these alkaloids in plant extract and pharmaceutical formulations. Pharmacognostic application of Vincristine and Vinblastine. Vincristine and Vinblastine are important anti-cancer drug derived from the Madagascar Previncle Plectranthus roseus. They are utilized in pharmacognosy due to their potent cytotoxic activity, including leukemia and lymphoma. So they are very much interesting. This is an interesting topic. Kindly listen to the topic, prepare your notes yourself, very detailedly write the assignment and submit to my office without fail. This is very, very important for your continuous assessment mark entry to the university. Thank you.